Dear friends, welcome back to Data Analytics Talks. Let's have a comprehensive overview based on DAMA DMBOK Chapter 6 today. From a CDMP exam perspective, it is important to focus on the core principles and best practices of data storage and operations. The key areas include understanding different storage architecture, the importance of access control for data security, the techniques for performance optimization like indexing and query optimization. And additionally, we should be familiar with the data governance practices such as data cataloging and data lineage tracking, as these are critical to ensuring data quality, compliance, and discoverability. And mastery of these topics will help us understand scenario based questions and demonstrate our ability to manage enterprise data environments effectively. So, welcome to data storage and operations. Data storage and operation is a critical function in data management, which encompasses the design, implementation, and ongoing support of data storage solutions. The primary objective is to maximize the value of data assets throughout their life cycle. It's starting from the creation or acquisition and extending all the way to the eventual disposition of data. So, this discipline ensures that data remains available, secure, and performant while supporting the organization's broader data strategy. So, we should start with the definition of data storage or understand what is data storage. The data storage and operation is the design, implementation, and support of stored data to maximize its value throughout its life cycle, from creation, acquisition, to disposal. Got it. Let me repeat that. The design, implementation, and support of stored data to maximize its value throughout its life cycle, from creation to disposal. And according to DAMA, this domain of data storage and operations can be divided into two main sub activities. So they are database support and database technology support. So database support means the direct management of maintenance of database to ensure their optimal functioning. And database technology support means it is focusing on the selection, configuration, and ongoing support of database technology and platforms. Okay, so these sub activities together ensure the reliability, integrity, and efficiency of data storage across the organization. So it's good to understand the goals of data storage and operations. So there are mainly three goals. First one is managing availability, which means ensuring the data is accessible to authorized users throughout its life cycle. There should not be uh, any unavailability of the data for the authorized users. Then second is ensuring integrity, which means protecting data assets from corruption, loss, or unauthorized modification. And finally, it is managing the performance of data transactions. It is optimizing the speed and efficiency of data transaction for business needs. So that is basically the goals. So these goals are foundational to maintaining trust in data and supporting operational and analytical processes. As we have already seen, every subject area has a context diagram in the DAMA DMBOK. And we have a context diagram for data storage and operations. And a context diagram outlines a framework for managing data storage and operations within an organization. And we have the explanation. It starts with the definition, the design, implementation, and support of stored data to maximize its value. And from a goals point of view, it's a manage availability of data throughout the data lifecycle, ensures the integrity of data access, and manage performance of data transactions. It's very clear from the goals. And we have the business drivers and the technical drivers. As we have already seen, we have the inputs, activities, and deliverables, which is supported by the suppliers and the participants of the activities and the consumers of the deliverables. So let's look at the inputs. The inputs are data architecture, data requirements, data models, service level agreements. And who are the suppliers? Data architects will supply the architecture, data modeler will provide the data models, then software developers, then application testing team. These are the suppliers. And the activities are manage database technology, under which we have the understand the database technology, evaluate database technology, manage and monitor database technology. And we have the manage database operations, like understand the requirements, plan for business continuity, develop database instances, manage database performance, manage test data sets, manage data migrations. And the participants are database administrators, database technology specialists, data modeler, data architects. And the deliverables is very important. Is the database technology evaluation criteria, database environment, migrated or replicated version data, disaster recovery plan, business continuity plan, database operations report. And the consumers are data modeler, data software engineer, application testing team, infrastructure operation team, executive and managers. And coming to the technical drivers, the techniques involve testing in lower environment using physical naming standards and scripting challenges. Then we have the tools like data modeling tools, database monitoring tools, database management tools, and developer supporting tools. And various metrics are data storage metrics, performance metrics, operations metrics, and service metrics. So this framework ensures efficient data management throughout its life cycle with clear responsibilities, outcomes defined at each stage. So I request you to go through this context diagram multiple times to understand what is happening within data storage and operations. So moving on, let's look into some of the essential concepts in storage. So that is database concepts. So it's nothing but understanding the core principles of how databases are structured and managed. Then data lifecycle management. So it's overseeing data from creation to disposal, ensuring compliance and value at every stage. Then we have types of administrators. So you have heard about production DBA, application DBA, procedural and development DBA, or NSA. So understanding these concepts are very important. So from a production DBA point of view, who manages the live operational database. And application DBA is focusing on supporting specific applications or databases. Then procedural or development DBA supports development and procedural aspects of database management. And NSA means Network System Administrator, who provides infrastructure support for databases. So we have the production database DBA, application DBA, procedural DBA, and NSA. Each role plays a distinct part in ensuring robust database operations. Okay. Now moving on to database architectural type. So we have centralized database, distributed database, federated database, blockchain database. So what is a centralized database? A centralized database, all data is stored and managed from a single central location. That is a centralized database. From a distributed point of view, the data is spread across multiple locations, enhancing availability and resilience. From a federated point of view, it is the integration of multiple autonomous databases into a single federated system. Okay, if you look at this diagram, you can see this is a federated architecture. We have a top level and we have the federation like location, different location A, location B, and location C. As I explained, is the integration of multiple autonomous databases into a single federated system. These location, these are all uh, integrated with a single autonomous system, and user can view all ABC. That is a federated system, and this federated system can be closely loosely coupled as well as tightly coupled. Okay, and we also having a blockchain database utilizing the blockchain technology for secure, decentralized, and data storage. Okay, so we have also in the modern environment, we also leverage the virtualization and cloud platform such as virtual machines, database as a service, managed database hosting on cloud. So coming to virtual machine, they are running databases on virtual infrastructure for flexibility and scalability. I'm sure you are all aware of what is a virtual machine VM. We can go to Azure as infrastructure as a service. You can spin up a virtual machine, you can install the database, and you can run the database in the virtual machines. And you can also use the database as a service. Cloud provide manage the database, reducing operational overhead. For example, Azure SQL is a database as a service. You can go and set up your database. You don't need to install, you don't need to manage, you don't need to update. So everything is managed by Microsoft. And we also having managed database hosting. Basically, they are outsourcing database management to specialized providers in the cloud. That is the managed database hosting. So these architectures support diverse business needs and operational models. The next topic in chapter 6 is essential under essential concept is database processing type. They look little important from an exam point of view. We have the acid and base. So let me break down acid properties for you in a simple terms. We have atomicity, consistency, isolation, and durability. So atomicity means think of this like an all in or nothing deal. Either the whole transaction happens or nothing does. There is no halfway. That is called atomicity. Then secondly, consistency. So this ensures that your data always stays correct. So before and after any transaction, everything checks out and follows the rules set for the data. That is consistency. And the third one is isolation. Even when many transactions are happening at the same time, each one goes about its business without interfering with other. That is isolation. There is no interference with others. Okay, so there are many transactions are happening, but everything behaves as isolated transaction. Then finally we have the durability. So once a transaction is done and saved, it is there for good. Even if there is a power cut or system failure, your data remains safe. That is durability. So ACID transactions, the transaction system support ACID transaction. Then understanding base. So base means basically available, soft state, and eventual consistency. So what is meant by basically available? The system always up and running. System is always up and running. So you can count on it being available even if it is not perfect every second. You remember? So system is running even though there is not perfect every second. So basically it is available. Secondly, soft state. What do you mean by soft state? The soft state, things might change in the system over time. Even if you are not making any update, it is flexible, not set in stone. That means not set in stone. It is flexible, changing every time. That is soft state. And finally, eventually, it is consistent. Eventually, consistent means don't worry if everything is not lined up right away. The system will sort itself out and become consistent after a while. So base is basically available, means system is available, but it may not be perfect every time. Soft state, things might change in the system over time. It's very flexible, nothing set in stone. Then eventually consistent. So even if something goes wrong, eventually everything will become consistent. Okay, that is called the processing. That is a processing type. So understanding these concepts is crucial for selecting the right database technology for specific use cases. So base works with big data, and the asset applies to the transactional data. Then the next is the data storage media, the disk storage area network, in memory columnar compression solution, flash memory. So disk storage area network SAN provides high speed reliable storage for enterprise databases. In memory data is stored in RAM for ultra fast processing in memory databases. Then columnar compression solution, they give efficient storage for analytical workloads by compressing data columns. If you need an example for this columnar compression solution, suppose a table stores sales data with a column for the region, and many rows have the value South India. So in a columnar storage system, all the values for the region column are stored together instead of storing South India repeatedly for each row. So that the entire data for South India is stored in a column. So the columnar compression can store it once and reference it for all matching rows. So greatly reducing the storage space. So this is especially beneficial for analytical queries that scan the entire column rather than individual rows. Then finally we have the flash memory. So they are solid state storage SSD offering high speed durability. So the choice of storage media impacts performance, cost, and scalability. And quickly we can see the database environments. We have the production environment, we have the pre-production environment, we have a development, test, sandbox, or experimental. I'm sure this is quite clear to most of you. Production, that's the real deal where the business operates actually. The pre-production, think of it as a final dressing rehearsal. Then development is where the development happens. Then quality, this is a systematic check to make sure software matches the quality standards and works as expected. Then integration testing is testing the integration pieces. User acceptance, where the end user is testing the feature. Then performance testing, the system is put through its pace to check how responsive, stable, and scalable it is under different workloads. Then sandbox is nothing but an play area, experimental area. So moving on, the DAMA DMBOK Chapter 6 talks about the database terminology and abstractions. So let's break down some common database terms in simple way. The database. So think of this as a well organized cupboard where all your important data is stored neatly and can be easily found when needed. That's a database. Then second is instance. So instance, this is just a running version of your database software, like having the cupboard open and ready for use. Then thirdly, we have the schema. Imagine a floor plan for your cupboard, showing how the shelves, tables, compartments, and their connections are arranged. That is nothing but the schema. Then we have the node. It's a big setup where you have many cupboards spread across different rooms. Each cupboard or server is called a node in the system. Okay, so understanding this term is a foundational for effective communication and management. So database, instances, schema, and node, they are the database terminology. Then we have the database organization, which is also important. We have hierarchical, the hierarchical databases, uh, the database model where data is organized in a tree-like structure with the parent-child relationship. That's a hierarchical database organization. Then we have the relational database organization where we have data store in tables with rows and columns using relationship among tables through keys. That is a relational database. And we have multidimensional or temporal relational databases. So what is a multidimensional is organizes data in cube, enabling complex analytical and reporting queries. They often used in OLAP systems. And temporal relationship manage data with respect to time, capturing historical changes and temporal validity. Then we have a third type called non-relational relational data. So they broad category of database they call NoSQL that store data without a rigid table structure, offering flexibility and scalability. And if you expand these non-relational, we can say column-oriented. They are spatial. They are object multimedia. They are flat file databases. They may be also key value pair. They may be triple store. So under non-relational, you can find a different category of databases. Okay, and the final one we have the specialized databases. So specialized databases, they are tailored for specific use cases or industries. So optimized for unique data requirements. Maybe you can say computer assisted design manufacturing. That's called CAD. So databases supporting design and manufacturing processes by storing complex engineering data and models. So that has a specialized database. And we have geographical information system is GIS. So GIS databases that manage, analyze, and visualize spatial and geographical data. That's a specialized database. Again, we have a shopping cart applications like they specialized database designed to handle and persistent shopping cart data for e-commerce platforms. Okay, so that's about database organizations. So DAMA DMBOK Chapter 6 also talks about some common database processes. Again, I repeat, you need to go through the chapter multiple times to get everything. It's only giving an outline. So what are the common database process is archiving, capacity and growth projections, change data capture, purging, replication, resiliency and recovery, retention, sharding. So starting with archiving. So what is archiving? So archiving refers to the systematic process of moving inactive or historical data from primary storage to long-term storage, kind of cold storage, ensuring compliance, cost optimization, and data retrieval when needed. We are not destroying it, but we are moving the non-performing data to a storage location, a cold storage location. And coming to the capacity and growth projections, so this involve forecasting future data storage and processing needs based on current trends and basic growth. And change data capture is also very important process. CDC, it is a process of identifying and recording change made to data in the database. So from a DAMA perspective, it supports data integration, synchronization, and auditing by tracking inserts, updates, and deletions. Okay, so it's very important. CDC is very important in data engineering. Then another data processing concept is purging. So purging is the permanent deletion of obsolete or unnecessary data from databases. And DAMA DMBOK highlights purging as an essential for maintaining data quality, compliance, and efficient resource utilization. Okay, that's about purging. Then we have something called replication. So replication involves creating and maintaining copies of data across different databases or location. Okay, what is the need of that? According to DAMA, this enhances data availability, supports disaster recovery, and improves access speed for distributed systems. Active and passive replications are the two types of replications. And also they have the horizontal data scaling and vertical data scaling. It also uses the technique called log shipping and mirroring for the replication part. Then we have something called resiliency and recovery. What are those? So this process ensures that databases can withstand failure and recover data after incidents. And DMA DMBOK stresses robust backup, failover, and recovery strategies to minimize downtime and data loss. Okay, then we have the retention. So retention means it's all about defining and enforcing policies for how long data should be kept based on business, legal, and regulatory requirements. And DAMA considers retention management vital for compliance and optimized storage. Then finally, it's the process is sharding. What is that? Sharding is a technique of splitting a database into smaller manageable pieces to improve scalability and performance. The data supporting high transaction loads very efficiently using this technique. That's sharding. So we have archiving, capacity and growth projection, change data capture, purging, replication, resiliency and recovery, retention, and sharding. Okay. So moving on, we have some activities for managing database technology. So first is access technology needs, establish technology architecture, selecting databases, implementing databases, configuring databases, performance tuning, and technology upgrades. I think they are very clear from the terminology itself. Basically, identify the requirement based on business objective, design the blueprint for database infrastructure, choose the appropriate data management system, deploy and configure the selected system, fine tune setting for optimal performance security, then continuously optimize the system for speed and efficiency, and finally keep the system updated for new features and security patches. These activities ensure that technology choices remain aligned with organizational needs. So moving on, we will see activities for managing database. So they are database design and modeling, data migration, backup and recovery planning, data security management, then monitoring database health, then we have incident management, then complaints management, then documentation. So these are the activities for managing database. So if I want to give an explanation of each of them, like what is the designing database and modeling, then structuring data to support business process and analytics, that is database design and modeling. And data migration is moving data between systems or environments. So backup and recovery planning ensures data can be restored after loss or corruption. Data security management, the protecting data against unauthorized access and breaches. Then monitoring and database health is proactively identifying and resolving issues. Incident management is about responding to and mitigating database incidents. Then compliance management is ensuring adherence to regulatory requirements. And finally, the documentation is maintaining up to date records of system configuration, procedures, and policies. So these are the activities, and for the effective management of databases, and effective management of these activities is vital for maintaining a reliable and secure data environment. And we can also look into some of the data storage and operations tools, and they have the data storage solutions, hardware and software for storing data efficiently, then data integration and ETL tools, and they extract, transform, and load tools for moving and transforming data. Then we have database monitoring tools. So basically, they are applications for tracking performance and health. Then finally, we have the database management tools, the software for database administration and maintenance. And the right tools streamline operations and enhance productivity. Okay, so moving on, we have multiple techniques to know about. Okay, so the first one is about some of the techniques used in data modeling. They are normalization and denormalization, and backup and recovery, basically regular backups, disaster recovery planning. And we have the data security where we use the encryption, access controls, and we have the performance optimization using indexing, query optimization, and we have the data governance, cataloging, and lineage tracking. And these are some of the techniques, database techniques we should know about for managing database. And that's all about chapter 6 of DAMA DMBOK, storage and operations. To conclude, data storage and operations form the backbone of enterprise data management. To ensure that data is always available, secure, and optimized for business needs. By practicing or understanding and implementing these concepts, architectures, tools, and techniques, organizations can derive maximum value from their data assets throughout the entire data lifecycle. So I request you to read the chapter a couple of times to assimilate and share your feedback as comments. If you have a better idea, better thoughts about this chapter, if I have missed something, please make it as a comment. And your comment will really boost me do better or more videos. I will come with chapter 6, data security, in the next video. Until then, bye. Thank you.